Hey everyone, here is the second video for the second page. So this is going to incorporate the answering of when we solve a quadratic with an inequality, but we're going to do it strictly through the graph at this moment. So the idea is we have f of x, which has already been graphed for us, okay? And they want us to graph the line 9, so remember that is a y-intercept of 9 with no slope, okay? And the idea is to describe, because there's an inequality, where the alligator's happy. So just carrying on with the theme, here's my blue, and according to this, I want the alligator will be happy on the part of the U that is above my line. So as far as highlighting my answer goes, here we go. Now, we can see actually where these meet, okay? If you can't tell these coordinates, let me point them out to you. This is -2, 9, and this is 2, 9. And since we're only solving for x, I actually just want the x values. So now what I'm going to do is erase the 9s because I don't need them. And I just want to describe where the alligator's happy. So let's put arrows on the end now. And arrows on the left are -infinity, arrows on the right are infinity. So if I describe in an interval where my alligator is happy, it goes from -infinity to -2, and then from 2 to infinity. And it will be parentheses the whole way because my inequality sign is not underlined. All right, the next one. So we will actually have to graph. So this is a cubed, so just to note that these are the points for cubed. And we do have a flip. We will be going right 2 and up 8. So since I'm going to have a flip, this flip will be changing the y values like this. So they're all going to become opposite or flip. And then I'm going to go ahead and just get rid of my old y's. So just like before on the previous video, I will start with 0, 0, and I'm going to go right 2 and up 8. So I end up right here. From there, I'm going to graph my other points. So starting where my red circle is, or the x, with this points, I'm going to go left 1, up 1. And I don't have room to go left 2, up 8, so I'll leave that one off. For this set, I'll go right 1, down 1. And then for the last one, I'll go right 2, down 8, which puts me right here. All right, so then I got my shape. And this time, we want our function, g of x, which is this kind of S curvy line, needs to be below my flat line of 0. So here's 0. And I want the part that's below. So if I get my highlighter out, that is, I want the part of this line, this curvy line that's below my red line, so right here. And arrow on the right, that's an infinity. Oops, that's an infinity, because this arrow on the left is my -infinity, and then I need this x value, which is 4. So my alligator will be happy from 4 to infinity, and again, all parentheses because my inequality sign is not underlined. All right, let's move to 13. So it does say calculator active. I think the only part that you wouldn't have the calculator on is the graphing part, but here we go. We've got two functions, f of x and g of x. And our job is to see where they equal each other. So this is going to be a strictly graphing calculator problem. So f of x equaling g of x. Okay, and just to set it up, x cubed minus 7x minus 3 equaling the absolute value of 3 minus 2x. So if you don't have your calculator, the graphing calculator, you can always use Desmos, which I'm going to pause the video and I am actually going to switch to Desmos on my screen. So give me a moment. All right, so I am in the Desmos calculator app. You could download the app on your phone or on your computer, and I'm going to type in one equation, so x, and then if you go down here, you're going to see this little bar, and you can raise your exponent with this cubed. I just arrow out to get out of that, and then minus 7x minus 3. And then I'm going to hit this plus sign over here, get one more expression to show up, and then I'm going to put in my absolute value, which if you look over here, you can see right here are some absolute value bars, and I'm just going to type in 3 minus 2x, like that. And I'm looking for where these two shapes meet. So let's get rid of this. And the nice thing is they're only meeting right here at this point of 3, 3. So visually I can see that my V shape with this kind of very curvy S is going to meet, because I only have to solve for x, where x is 3. All right, so we have this function on the right. The picture on the right will go for questions 14 and 15. So given the graph of the function, there it is, find the maximum or minimum of t, and for what value does the max or min occur? Well, because this is a flipped parabola, we are actually having a max right here, and this value is my max. So I'm going to say I have a max of, and I'm just going to write the whole decimal down. And then where did that occur? Where x is 1.109. All right, the next thing we have to do is, where is my function increasing? So remember, when we look at a graph from left to right, we go like this. This is increasing. The only thing missing here is my arrow. So on the left, x is negative infinity, but it's going down, so negative infinity. And we use our x values to describe an interval of increase. So it's increasing from negative infinity to this 1.109. And a reminder, increase and decrease always has parentheses. Okay, next one. So for problems 16 through 19, we're going to use the following situation and table. The table shows the resistance of a coil of copper wire at various temperatures. And the equation for the resistance in ohms with respect to temperature in degrees Celsius is as follows. So what we want to do is use the equation right here to find the resistance of the coil when the temperature is 22.5 C degrees. So T up here is my temperature, and then this is going to be my resistance based on the temperature. So all I have to do is go to my equation and put 22.5 in for C, and then I would just let the calculator do all the work from here. So order of operations would have me multiply first. So if I took my 0.38 and multiplied it with my 22.5, I would get this number. And then I should just add it to my 92.4. And when I do, my resistance is going to be 100.95 ohms. All right, now we're going to again use the equation to predict when the resistance is 101. So I'll put that over on the left side where the R of t is. And because there's one type of t, I'll just get t alone. So I'm going to start, by subtracting my 92.4 from both sides, which leaves me with 8.6 on the left and my 0.38 t on the right. And then I'll just divide by that 0.38. And the temperature that would happen is 22.6 degrees Celsius. Okay. So the next question they want to know is, on what interval is the resistance? So the resistance formula is this. greater than 101. Well, we've already solved this problem for if it is 101, that's what we did right here. So when the temperature is 22.6 degrees, it's exactly 101. But what I want to know is, where is this line? So this is a line that goes uphill because I begin at 92.4 and my slope is positive, so something like this. And then I have this flat line of 101. Let's get a different color. And this says you want the part of the line that is above my blue line. So that would be here. And where they meet is 22.6. And that's an arrow on the right, so I would say infinity. And it's from 22.6 to infinity. Yeah, and underline. All right, and then using correct units, describe the meaning of the slope in context. Well, m is always married to x. So my m is 0.38, but if you remember our story about the tables, we've got our wine glasses on the top, which is our ohms, that's y, and our x is in the denominator, which is our temperature, Celsius. So I would say the resistance increases because I have a positive value, 0.38 ohms every 1 degree Celsius. All right, let's take a look at the next page, and that was it. That's the whole page. That is your final review. Oops, take it back. I missed these problems 8 through 10, so let's talk about these real quick. Just solving a couple different ways. So number 8 has more than one type of x, so I will move the 2 over by subtracting it. And then because that is more than one type of x, I'm going to try to factor it. So I need factors of 2 that make 3. So I'm going to get x and x are all I need for my neighbor so far to make the x squared. And now these loops can make the 1x and the 2x. Doesn't matter which one does what because we're starting with our x's here. So x times a positive 1 can make 1x, and x times a positive 2 can make 2x. I then set each factor equal to 0 and solve. So there's one solution, and here's the other solution. All right, my next problem, I have one type of x, so I'm going to get the x alone. So the first thing that I'm going to move is the addition subtraction, so I'm going to subtract the 8, which gives me -9. Then I'm going to move my multiplication division, and the easiest way to get rid of this fraction is to multiply by the reciprocal. So I'm going to move this down here. So on the left side, I still have my parentheses cubed, and now I have a -27. And now to get rid of that exponent that is cubed, I will use specifically a cubed root. That leaves me with x minus 1, and the cubed root of -27 is only one value. It's -3. And now if I just add the 1 over, my answer is -2. And the last problem. So I want to look for factors of -14 that make 3, and it turns out there's not. So we will do the quadratic formula, where a is the number with x squared, b is the number with x, and c is the number that has no x. So I will get my answer by doing x equals opposite of the b plus or minus, and I'm going to take my b value and square it, -4 with a and c, and then all of this will be over 2 times a, and then I ask that you get that square root to one number. So if you want to do this without your calculator, you would do your exponent first, and then you would multiply, which gives me here -56. But when I have 9 and I take away -56, that's like 9 adding to 56, and I get 65. And this is a great answer. But remember, you can press the alpha y equals button, enter on your calculator, type this in twice, once with the plus sign, and then once with the negative sign. So with the plus sign, here's my answer. Let's go that far, and then I can just do it again, and I would just change that plus sign into a minus sign, and then here's my other answer if I want these as decimals. So Any of those would work. And now our video is done.